This section asks us to solve quadratic equations using different methods. The first method that we looked at was factoring, and we need to solve these particular equations by factoring. We said that to solve a quadratic by factoring, we want to make use of that zero product property, which wants us to get one side, usually this right side, set equal to 0. Then we can use the idea that products that equal 0 mean that one of the factors has to be 0. So in this case, I will subtract the 8x from both sides of the equal sign, which leaves me with 2x squared minus 8x equals 0. The zero product property means that we have to have a product of two things. In this case, we have a difference, that subtraction there. We have to get it rewritten in terms of multiplication. So to do that, I'll factor out a 2x. Each term has a factor of 2x. And if I do that, I'm left with x minus 4 inside the parentheses equals 0. You can see that if I distribute the 2x back into the parentheses, 2x times x is 2x squared, and 2x times minus 4 is minus 8x. So I was able to factor out that 2x. Now I can say that I have two things multiplied together that equal 0, so one of them has to be 0. Either the 2x equals 0, or the x minus 4 equals 0. If I solve each one, divide both sides by 2 over here, and I get that x equals 0. Add 4 to both sides over here, and I'm left with x equaling 4. So my solution set is that x could equal 0 or 4. For number 9, we want to get this quadratic into standard form so that we can solve by factoring. I can add the 6t squared to both sides, and also subtract, well, let's do it one step at a time here. That will give me 6t squared minus 8 equals 22t, after my 6t squareds cancel out. Now I can subtract the 22t from both sides. I have to have one side equaling 0 when I'm solving by factoring. And if I put this in standard form, that leaves me with 6t squared minus 22t minus 8 equals 0. One way to approach this problem would be to notice that every one of my factors here, or I'm sorry, every one of my terms in this problem rather, the 6t squared, the minus 22t, the 8, and the 0, are all divisible by 2. So to make my numbers a little bit easier to work with, what I can do is go through and divide every term by 2. Doing this leaves me with 3t squared minus 11t minus 4 equals 0. This isn't a necessary step, but it definitely makes your numbers a little bit easier to work with. To factor, because now I'm dealing with a prime coefficient, the 3t squared, I know that the only combination that can work to get me 3t squared is 3t and t. As far as the negative 4 goes, or that minus 4, I know I need to split that negative 4 up into factors to put inside my the rest of my parentheses here. Well, I can kind of use the idea that I need this particular factor times whatever's here, and then this times whatever's here. I need these to add up to negative 11t. So a factor of negative 4 that I can multiply by 3 to get me kind of close to the negative 11t would be minus 4, which would leave a plus 1 here. It's kind of trial and error, but again, we can make educated guesses here. If I were to multiply these back together, 3t times t is 3t squared, 3t times minus 4 is minus 12t, 1 times t is plus t, so I have minus 12t plus 1t, which gives me that negative 11t. And then 1 times negative 4 is my minus 4. So this is the combination that works. If you're still not sure, write out the multiplication. Make sure when you multiply these two factors back together that you end up with the 3t squared minus 11t minus 4. In any case, though, I now have this particular problem written as a product of two factors that equal 0. That means one of them has to equal 0. it could be that 3t plus 1 equals 0, or it could be that t minus 4 equals 0. I'm running out of room. On this side, if I subtract the 1 from both sides, I get that 3t equals negative 1. Divide both sides by 3, and t is negative 1/3. On this side, I can add the 4 to both sides and get t equals 4. So my solution set for this particular problem would be negative 1/3 and 4. Last, to solve this particular problem by factoring, again, I need it set equal to 0, so I will subtract that 10 from both sides, which leaves me with 3w squared plus 13w minus 10 equals 0. Again, to factor it, I can look at this first term and recognize that it's prime, so I can write these as 3w and w. They're going to be set equal to 0. And I can also use that technique again of looking at this last term, which is negative 10. I need factors of negative 10 to go in these blank spaces yet. I also know that when I take the 3w times whatever's here, and then whatever's here times w, combining those I have to get positive 13. So I want to kind of think about a factor of negative 10 that when I multiply it by the 3w will get me kind of close to a positive 13. I would say that a plus 5 would fit that bill, which means that I would have to have a minus 2 in this space. Off to the side, I'll multiply 3w minus 2 times w plus 5. I'll multiply those together just to verify that I do get back the 3w squared plus 13w minus 10. Well, 3w times w gives me 3w squared. And then I have 3w times the 5, which gives me plus 15w. If I then distribute the negative 2 to both of those terms, that gives me negative 2w minus 10. Combining my like terms, I do get that 3w squared plus 13w minus 10. So I was able to get that combination that works. If you hit on a combination that does not work, try again. Don't erase the one that doesn't work, but keep it in front of you so that you don't try that same combination again. In this case, though, we did get the 3w minus 2 times w plus 5. I have two factors that are multiplied together that equal 0. One of them has to be 0. So it's either the 3w minus 2 that equals 0, or the w plus 5 that equals 0. If 3w minus 2 equals 0, I can add that 2 to both sides and get that 3w equals 2. Dividing both sides by 3 gives me w equals 2/3. On this side, I can subtract 5 and get that w equals negative 5. So my solution set would be negative 5 and 2/3.